Hello, my name is Jaden. I'm from Distance Education Institute and I'm grade 9. So this is my presentation on water level monitoring. And I'm going to start. How do we start? It's not working. Okay. So first off, there are some questions. First is, why is this needed? So why do we need this whole thing that I made? So the first one. So some of you may know that the government provides public CCTV cameras and you can check the water level in those cameras. The problem is sometimes floods can happen quickly and having someone watch over these cameras, even in shifts, is not very efficient. So instead, I created a program that does all of that instead. So, second question, how is it made? I made it using the programming language Python, and I also integrated it with a line bot for the alert system. And the third one is, why line specifically? It's because it is one of the most popular messaging applications in Thailand, and it also has bot integration, so it's relatively easy to implement. So let's start. This is how it's made. It's pretty simple, so I made it into a flowchart. The first step is get video from CCTV. So we just get the video from the URL and put it in a MP4 file. Next is to process the video frame by frame and just do whatever image operations you want to find the edges of the water level. And the third one is to detect the water level in pixels. So we find the edge of the water level and then we find the lowest edge of the water level. And then once we found that in pixel form, we can then interpolate it into centimeters using statistics. After that, we check if the water level is over a specified threshold, and if it is, it sends it to the LINE API. If someone asks for the water level and in the bot will send and reply with the water level in the message. So we'll go through this from the video CCTV all the way to the alert. So first off, get video from CCTV. Normally this would be pretty easy, but the reason why this is a lot larger than it should be is that you have to get the video URL first from a different static URL and then finally get the video. I don't know why this is, but it works. Next is to process the video. So first off, we crop the video from what you see here, the whole thing here. We crop it so there's only the meter left. Next is to convert it into black and white or monochromatic. After that, we then blur the video. It just makes it more accurate for some reason. I'm not very sure why. And after that, we find the edges using county edge detection. All of this is made by OpenCV. It's something good. It's a library that can process images. And the next one is to detect the water level in pixel form. So we just go from bottom to top, see if there is an edge in the bottom in the frame, and if there's none, then we go up 1 pixel. Just keep repeating this until we find one. After that, we add it to a list. Once we find the list here, we first find the median of all that in the list, the median of all the frames. Once we find that, we find the median of the pixels, then we interpolate it. All this is separated into a bunch of variables for it. So once we interpolate it, then we get the water level. We get this with a reference like every 50 frames, this is the water level, water level, water level. And this one is the alert system. It's just a bunch of if statements to see if it goes up or down. And if it goes up, then it sends an alert. And this is the line by part. So I'm not going to explain this very much because there's a lot more documentation for this somewhere else. But this is basically it. There's also hourly notifications if you want. And this is the result. The line what I made. So if you send any message, it responds with the water level in centimeters. If it's the status, if it's normal, high, very high, or critical, and also when the next alert is. And this is the actual results that I got. It is captured from midnight of October 12 to 11 p.m. of October 12, 2024. So this is the side-by-side images, so you can see it goes down and then up. We also map that into a graph instead. So the blue line is the actual water level that we just measured by eye, and the orange one is the system detected water level. As you can see, the first part of this is very stable and very consistent. The last part here is less consistent, and one of them also has a pretty significant drop from here. I do not know why that is. It's in between the captured frames and it all looks normal over here. So I don't know why. Yeah, that is it. It is the end. Source code is in my GitHub profile. Be warned though, it does not work right now. The website is down for some reason. Maybe it only opens on the rainy season. But the website is not working right now.
Okay, thank you very much for your presentation. Any question from audience?
I wonder why would you add blur to the image before processing it?
I don't really know as well, but in the tutorials that I made, that I looked up, they also added blur, so I added blur. It also works better for some reason as well.
So you have compared between add the blur function and don't have the blur function with the number detect result of your analysis.
Yes, I did compare it, and it's in here, but I did compare it. The one with the blur is more accurate.
Oh, the one with the brace is not accurate.
It's more accurate.
It's more accurate. But this line is the exactly one and the blur one, but we don't see the line with no blur image.
No.
No. So may I ask some questions? How frequently do you get the video from the URL? Like every 5 minutes or every hour? Like you are not at.
So the video, it's like a very weird live stream. So once a video finishes, it keeps looping that until it finds a new one. Because like, as you can see from the first one here, we got video from CCTV. So it goes to the static URL that shows you where the
Yes.
URL video is. And if it's different, then we go through the whole thing. If the URL is the same after we already processed it, we don't do anything.
I see. So the difference is
There's
it's
like,
not by the time. It's like the
Yeah, it's
difference
just-
between.
if there's a new
Uh-huh.
data, then it just processes it.
Okay, the last question.
I have one more. Is there any specific condition from the perspective of the of the CCTV that you need, like to for a better result. Do you know what I mean? The perspective of the camera on scene and the condition of the image. Yeah.
The angle of your camera,
Uh-huh.
the wide picture.
I don't really account for that, that's why I use interpolation. I just check to see every 50 pixels in the thing, it has a reference with centimeter that says like if the pixel is at 50 centimeters, then it is this water level. So we just find the middle of those.
Okay. So you said like the angle is not affect the accuracy. How about the light condition? The
Light conditions
Yeah.
do affect it, as you can see.
Yeah.
Over here, when it detects the edges, you can see that the light reflects down here when the street lights turn on. So they will detect that there's an edge here, and then it makes it so the water level is lower than it should be. I mostly mitigated this by checking to see if the water level that we detected before is within 5 centimeters